So today we're going to learn the basics of naming organic compounds. Organic compounds contain carbon, hydrogen, and other elements. So first we're going to start off with the hydrocarbons, which contain just carbon and hydrogen. So these functional groups are the alkanes, which have carbon single bonded to hydrogen and other carbon atoms. The formula for these alkanes are CnH2n plus 2. And an example is ethane, C2H6, which looks like this. So that's ethane. Next, we have alkenes, which have carbons double bonded. And the formula is CnH2n, and an example is ethene, which looks like this. So that's ethene. Next we have the alkynes, which have triple bonded carbons, and their formulas are CnH2n minus 2, and an example is ethyne, which looks like this. Finally, we have the aromatic hydrocarbons, which have the formula CnHn. An example is benzene, which looks like this. And these are all bonded to hydrogens and to each other. And there are what they call resonance structures, so they kind of go between double bonds and single bonds, so sometimes people draw them as a circle. And then we have cyclic alkanes, which have the formula CnH2n. This right here is an example, and it's called cyclopropane. First, we have the alcohols. This is the functional unit of an alcohol, and an example is the simplest methanol, CH3OH, and it looks like this. So that's methanol. A closely related functional group is that of the ethers, and this is its functional unit. It's very similar to those of alcohols, except instead of the H, it has a continued carbon chain. And an example is dimethyl ether, which actually looks like this. That's dimethyl ether. The next functional group are the amines, and they have a carbon single bonded to a nitrogen, and an example is ethylamine, which looks like this. And that's ethylamine. A very closely related functional group is the amides, and they look very like the amines, except they have an additional oxygen double bonded to the carbon. And an example is ethanamide, which looks like that. There. Aldehydes and ketones are very similar. So this is an aldehyde functional group right here. The suffix for all aldehydes is Al, and an example is ethanol, which looks like this. Next, we have the ketones, which looks just like the aldehydes, except instead of this hydrogen, we have this continued carbon chain right here. And our example of a ketone is propanone, which just has these hydrogens attached. So that's propanone. And then finally, we have the carboxylic acids and the esters, which are also very similar. The carboxylic functional group looks like this, with the carbon in two oxygens, one double bonded and one single bonded, and the suffix for all carboxylic acids are OIC acid, and our example here is ethanoic acid, or commonly known as acetic acid, which looks like this. So that's acetic acid. And then esters, which are very similar to carboxylic acid, have this very similar functional group, except again, the hydrogen is replaced with a continued carbon chain. And our example is methyl ethanoate, which looks like this. That's methyl ethanoate, and suffix for all esters is OATE.